All right, welcome. If you're gearing up for your A-level IT exams, then you are in exactly the right place. In this explainer, we're going to go way beyond just textbook definitions. We're going to get into the really powerful forces that are, right now, reshaping our entire world.
So here's our game plan. First, we're going to explore how tech is actually altering reality itself. Then we'll jump into the intelligent machines that live in it, we'll uncover the future networks connecting them, and we'll see how physical stuff gets made is being totally transformed. Oh, and definitely stick around for a super quick recap and a few exam-style questions to make sure all this stuff really sinks in.
Okay, let's dive right into Section 1, Altering and Enhancing Reality. We're talking about technologies that are fundamentally changing how we see and interact with the world around us. This is where the digital and the physical don't just meet, they actually start to merge.
All right, let's nail a classic exam question right away. What is the difference between AR and VR? Look, the main distinction is actually pretty simple. Augmented reality, or AR, adds digital stuff to your real world. Think of an app that shows you what a new sofa would look like in your living room. Virtual reality, or VR, replaces your world completely. It plunges you into a totally computer-generated environment. So here's how to remember it. One enhances reality, the other one substitutes it. Simple as that.
But AR and VR, they're really just the tip of the iceberg. There's a much broader and you could argue more impactful field called vision enhancement. This is all about augmenting human sight. And not just for fun and games. We're talking about critical applications that can help people and boost professional performance, which can radically improve someone's quality of life and what they're capable of.
And the real-world applications? They are just incredible. I mean, think about the head-up displays that project your speed right onto your car's windscreen, or night vision goggles for the military, or get this, smart glasses that can actually guide a surgeon's hands during a really complex procedure. For your exams, these are perfect, solid examples that'll show you really get the concepts.
So we've changed how we see the world. What's next? Well, now let's build machines that can think and act in it. Welcome to Section 2, the rise of intelligent machines.
So what even is artificial intelligence? Getting this definition down is absolutely crucial. At its heart, AI is all about mimicking human intelligence. It's not just about a computer following a bunch of rules someone programmed in. No. True AI involves solving problems, learning from experience, and, this is the most important part, adapting to new situations all by itself without a human telling it what to do.
So how does all that intelligence actually get put to work? Well, through robotics. And the best way to get your head around it is with this simple three-step loop. First, the robot senses its environment, with cameras and sensors. Then it processes all that data with its AI brain. And finally, it executes an action using motors and actuators. Sense, think, act. That is a perfect framework for an exam answer.
And this brings us to the perfect real-world example that ties all of this together. I mean, seriously, what does it actually take for a car to drive itself?
Well, the answer is a combination of everything we've just been talking about. These autonomous transport systems use a whole suite of sensors for that sensing step. Then, really powerful AI does the thinking part to make those split-second critical decisions. And this isn't just about self-driving cars. It's the same tech behind delivery drones and even those automated baggage systems you see at the airport.
Okay, so we've got intelligent machines. Now we need to connect them all together. Let's get into Section 3, Future Networks. You can almost think of these as the invisible nervous system for our entire tech world.
All right, let's demystify blockchain with this diagram. It's actually not as complicated as it sounds. It all starts when someone makes a transaction. That gets packaged up into what's called a block. That block is then sent out to all the other computers on the network. They all check it, approve it, and then add it to the chain. Now here's the magic part. Each new block is cryptographically linked to the one before it, creating this digital chain that's incredibly secure and pretty much impossible to change.
Next up, a term I'm sure you've heard 1,000 times, the Internet of Things, or IoT. The definition itself is simple, but what it means for the world is huge. It's all about taking everyday physical things, sticking sensors in them, and connecting them to a network so they can send and receive data.
And the sheer scope of IoT is just massive. It goes all the way from the smartwatch on your wrist and the smart lights in your home to really critical industrial sensors that are monitoring an aircraft engine while it's in mid-flight. The whole goal is to create this world of responsive, interconnected objects that are constantly talking to each other.
So far, we've talked about new ways to see, new ways to think, and new ways to connect. But what about new ways to actually make physical stuff? Let's talk about it. Welcome to Section 4, Physical Production.
This brings us to 3D printing. Now, the key exam term you absolutely have to remember is additive manufacturing. Think about it this way. For centuries, we've made things by being subtractive. You start with a block of something, and you cut material away. 3D printing does the complete opposite. It adds material, building an object up from nothing, layer by tiny layer, straight from a digital design.
So why is this such a game changer? Well, it's all about flexibility. It allows companies to do what's called rapid prototyping, to test out new designs almost instantly. It can create incredibly complex or customized one-off parts on demand, and a lot of the time, it's way cheaper and faster than making traditional industrial tools or molds.
Woo! Okay, we have flown through some enormous topics, so let's do a really quick rapid-fire recap of the absolute essentials you need to have locked in for your exam.
This table right here is your perfect snapshot for a last-minute revision. You've got AI mimicking intelligence for things like autonomous transport. You've got AR overlaying reality, while VR completely replaces it. Blockchain is your secure, decentralized ledger. IoT connects all our everyday devices, and 3D printing builds physical objects right from a digital file. Seriously, pause here, take a screenshot of this. It's your ultimate cheat sheet.
And now it is over to you. Look, the absolute best way to revise is to actively test your own knowledge. So let's run through a few exam-style questions just to see what's stuck.
First one up. Explain the main difference between AR and VR. Now, to get the full 4 marks, you're going to need a really clear example for each one. Go on, pause and have a think about your answer.
Okay, next question is all about IoT. Imagine you're a company monitoring a fleet of delivery vans. Describe 2 specific types of data that the IoT sensors on those vehicles could be collecting. What would you want to know?
And here's a big one. This is for 6 marks. Think back to that diagram we looked at. How do the features of blockchain, the cryptographic links, the distributed network, how do they make sure that once a record is made, it can't be changed?
And for one last thought, let's just zoom out. Beyond the exam, it's so important to remember that these aren't just separate topics in a textbook. They're all starting to converge, to build on top of each other, and they are fundamentally changing our world. The real question isn't just what are they, but what comes next. Good luck with your revision. You've got this.